Welcome to a review of factoring degree n polynomials. So I'm just going to run through a variety of techniques we have available to us. First one will be factor by grouping. So for example, let's go ahead and factor 2x cubed plus x squared plus 8x plus 4. The general idea is we are going to group the first half of the terms and the second half. So we are looking at 2x cubed plus x squared, then plus, so 2x cubed plus x squared in parentheses, and then plus 8x plus 4 in parentheses. Then we factor out the common factors. So we are looking at x squared times in parentheses 2x plus 1. In the second group, we can factor out a 4, and we're left with 2x plus 1. If factor by grouping works, so if these match, then we can just pull out the common factor. So if these match, then we can factor it out. So we can pull a 2x plus 1 out front, and we are left with x squared plus 4 at the end. Next up, I'm going to go ahead and do forced factor by grouping. So here we have an odd number of terms. So the general idea, so we have an odd number of terms. So what we're going to do is we're going to split the middle term between the two groups. So we will have 4x to the 4th minus 24x cubed plus something times x squared for our first group. Then plus something times x squared minus 12x plus 3. If factor by grouping works, then the sort of what we would multiply by to get from the first term in the first to the first term in the second should be consistent for each term. And then these should add to the middle term. So in this case, they should add to 8 for 8x squared. Okay. So what we're going to do is we have 4x to the 4th times some unknown should equal blank x squared. Negative 24x cubed times that exact same unknown should equal negative 12x. And something x squared times our unknown should equal positive 3. If this is true, then if we can find things that make this true, then we're good. So based off of this third term, our question mark would have to be 1/2 times 1 over x squared, if this works out. So if we use that question mark, then we would have this blank here should be equal to, I'm going to do, so this is the first thing we did. And second, our blank should be equal to we do 4x to the fourth times 1/2 over x squared. We should have 2. And then for our last one, we are looking at what x squared times 1/2 times 1 over x squared would equal 3. That blank would have to equal 6. 6x squared times 1/2 times 1 over x squared would give us our 3. So we just need to check. Does 2 plus 6 equal our desired 8? In this case, yes. And so this is our group, our split. So we have our split. The first blank was actually here. I should label these. Let me label. So this will be A and B. So the 4x to the fourth times question mark should equal bx squared. So we get that b is equal to 2. The ax squared times question mark should equal to 3. So we get that a is equal to 6. So we are looking at 4x to the fourth minus 24x cubed plus 6x squared plus 2x squared minus 12x plus 3. We now have our 6 terms. We can go ahead and do our factor by grouping. I need to give myself a little more space. So from here, running factor by grouping, this first factor, we can go ahead and pull out a 4x squared. So we have 4x squared times x squared minus 6x. Sorry, let's pull out a 2x squared. So if I pull out a 2x squared, no, sorry, I am going to aim for a 1 in front. Pull out a 4x squared, we are left with x squared minus 6x plus 3/2. If I pull out a 2 from the remaining one, we have 2 times x squared minus 6x 3/2. Obviously you don't, sorry, obviously you do not have to pull out that 4. You could have pulled out a 2 if you wanted. Then we can go ahead and take this x squared minus 6x plus 3/2, pull it out front. And so we have x squared minus 6x plus 3/2 times 4x squared plus 2. Again, we could have done 2x squared minus 12x plus 3 times 2x squared plus 1 as well. All right. Next up, we have the option of replacing an x to the k with x. So this is useful if we skip powers of x. So useful if we skip powers of x. So you're just going to take your lowest power, set that equal to capital X. So this is our lowest visible power. Then x, capital X squared is just x squared squared, which is x to the fourth. What else we have? And so we have capital X squared minus 6 times capital X plus 8, which we can then factor as capital X minus 2 times capital X minus 4. And we are looking at x squared minus 2 times x squared minus 4. And then, of course, we can keep factoring as x plus root 2 times x minus root 2 times x plus 2 times x minus 2. So this is a trick. You do not need to do the rewriting in terms of capital X. You can just recognize this as x to the fourth is x squared squared and leave it in that format as well. Another thing that's useful to look for is recognizing powers of x minus a. So x minus a to the n is n choose 0 times x to the n minus n choose 1 times a times x to the n minus 1 plus n choose 2 times a squared times x to the n minus 2 plus all the way down to n choose n times a to the nth. And then, of course, we will have -1 raised to the n since our powers are alternating. Or since our signs are alternating. So for example, if we have x to the 5th minus 10x to the 4th plus 40x cubed minus 80x squared plus 80x minus 32, we're looking at x to the 5th. So we're looking at n equals 5. So we're going to check. Does -32 equal -1 to the 5th times 5 choose 5 times sum a to the 5th? In this case, a equals 2 works, right? And then we need to check, does the whole thing fit? So we'll just go through and try. So try with, we're going to try x minus 2 raised to the 5th. Note if all the signs are positive, so if we have x plus a to the n, then all the signs are positive. Otherwise, it's the same idea. So let's try x minus 2 to the 5th. So this would be x to the 5th plus, 5 choose 0 times x to the 5th plus 5 choose 1 times, minus 5 choose 1 times 2 x to the 4th plus 5 choose 2, not 5 halves, 5 choose 2 times 2 squared times x cubed minus 5 choose 3 times 2 cubed times x squared plus 5 choose 4 times 2 to the 4th times x. I need to just slide this all over a tiny bit. So times 2 to the 4th times x, and then we have minus 5 choose 5 times 2 to the 5th. If you do not remember your binomial coefficients, you can do your little triangle, 1, 1, 1, 1, and then 1 plus 1 is 2, 1. 1's all down the diagonal or outsides, and then 1 plus 2 is 3, 2 plus 1 is 3, and 1. And we have 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1. And then we have 1 plus 5 is 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1. So those are our binomial coefficients. So we have 1x to the 5th minus 5 times 2x to the 4th plus 10 times 4x cubed minus 10 times 8x squared plus 5 times 16x minus 1 times 32. And we get x to the 5th minus 10x to the 4th plus 40x cubed minus 80x squared plus 80x minus 32. This is precisely what we had started with. You can't see it all on the same screen. There we go. X to the 5th minus 10x to the 4th plus 40x cubed minus 80x squared plus 80x minus 32. That is precisely what we had. And so we get that our factorization is x minus 2 to the 5th. For this, if you have something in front of the x to the 5th, you could factor it out from everything. Or in place of x, you could put like 3x all raised to the 5th in your formula. Last up, this is the last thing I would use. This is a last resort. This is typically a last resort, unless you really love it. Which essentially says if we have polynomial a naught x to the n plus all the way down to a sub n, then where all the a sub I, so a0 through an, are integers, then if bx minus c is a factor, then b is a factor of a naught, and c is a factor of a sub n. Essentially, if we think of it, if we have bx minus c times something equals a naught x to the n plus a sub n, the only term with x to the n will come from the leading p0 x to the n minus 1. So we'll have b times p0 is a naught. And then whatever we have at p sub n minus 1, that would only come from the constant negative c times p sub n minus 1. That would have to be equal to a sub n. Right now, the fact that this holds true is no guarantee that it is a factor, but if it is a factor, it must take this form. And so essentially what we can do is we can just check those possibilities. So here our a naught is 1, and our a sub 4 is negative 3. So the possible factors are plus or minus 1, and the possible factors of negative 3 are plus or minus 1 and plus or minus 3. So we get the possible factors. You can choose to just use the positive version of the E naught term, and then you'll have to use both of the others. So possible factors, we could have x plus 1, x minus 1, x plus 3, or x minus 3. Note, if we put a negative in front of the x, then it would just be the negative times the opposite version. So note, negative x plus 1 is just negative in parentheses x minus 1. So in general, if we have negative bx plus, if we have negative bx minus c, this is just the same thing as negative in parentheses bx plus c. So we only need to do the plus or minus on the c component. So we have 4 possible factors, and we just pick one and try it. Okay. So we'll just pick one of our factors to try. You can do long division. You can just build out the polynomial whichever way you want. I tend to just build it out. So if we have x plus 1 times blank is equal to x to the 4th minus 4x cubed plus 2x squared plus 4x minus 3. We'll just try it. So we would need x cubed to give us our x to the 4th. So then this would be x to the 4th plus x cubed. So to be minus 4x cubed, we would then have to subtract off 5x cubed. So we would have a minus 5x squared times x gives us that minus 5x cubed. And we have a minus 5x squared. To land on 2x squared, we would need a plus 7x. So we will need to do a plus 7x times 1. Sorry, that should have been a plus 7x squared, right? And then, so we have 7x times x, and then we also have a 7x times 1, so now we have a plus 7x. We want to be on 4x, so we need a minus 3x. In order to do minus 3x, we have negative 3 times x will give us negative 3x. And then we end with minus 3, and we do get what we want. Again, this is equivalent to essentially doing long division, or you can do synthetic division, whatever format you're comfortable with. If we want to do long division, we have x cubed minus 5x squared plus 7x minus 3. We try x plus 1. X goes into x cubed, x squared times, then multiply. We're looking at x cubed. Sorry, that shouldn't have been. This should have been x to the 4th minus 4x cubed plus 2x squared plus 4x minus 3 was our target. And x goes into x to the 4th, x cubed times x is x to the 4th, x cubed times 1 is plus x cubed. Then we subtract, we get negative 5x cubed plus 2x squared is what we're looking at here. X goes into negative 5x cubed, negative 5x squared times That gives us negative 5x cubed minus 5x squared. Again, we subtract. We now have 7x squared plus 4x. X goes into 7x squared, 7x times. We have 7x squared plus 7x. We subtract. We wind up with negative 3x. Pull down the negative 3. X goes into negative 3x minus 3 times. Multiply, we have negative 3x minus 3. We subtract, we do get remainder 0. And so we're set. So again, we wind up with x plus 1 times x cubed minus 5x squared plus 7x minus 3. From here, we can run the same thing again. So we can try, say, I don't know, x minus 3. We can try x minus 1. Up to you what you want to try. So let's try now x minus 3. And it's in x cubed minus 5x squared plus 7x minus 3. At this point, we no longer need to try in the large polynomial. If we try this, we have x cubed minus 5x squared plus 7x minus 3 inside. Divide by x minus 3. So we would have x squared. That becomes, once we multiply, x cubed minus 3x squared. Do our subtraction, you wind up with negative 2x squared plus 7x. X goes into negative 2x squared, negative 2x times. So we have negative 2x squared plus 6x. If we do our subtraction, we wind up with x. Pull down the minus 3. In this case, it just worked out that I did pick the one that works. And so we're set. So we now have x minus 3. So we had x plus 1 originally times x minus 3, and now we have x squared minus 2x plus 1. X squared minus 2x plus 1, we know how to factor. So we have x plus 1 times x minus 3 times x minus 1 squared. So it turns out that we could have chosen anything but x plus 3 and had our long division check out. This one, because I did pick a prime number for my constant and the coefficient in front of the x to the n was 1, we only had 4 things to try. But if we have anything other than primes, we wind up with quite a few different factors to try, and sometimes you have to try quite a few before you land on the one you need. So I tend to use this one as a last resort. And I tend to prefer some of the other techniques that we had available to us. So whether you spot a special power, or you can do your forced factor by grouping, or just your regular factor by grouping. Those are all much more convenient and typically faster.